Hello everyone. We'll discuss about stereochemistry part 2 in this video. In our previous videos, we had a discussion about stereochemistry fundamental aspects in as part 1 up to enantiomers. Now we will have a discussion about diastereomers in this video. What is diastereomers? Simply, diastereomers are defined as non-mirror images or non-identical isomers. So, the compounds having same molecular formula and sequence of bonded elements but which are non-superimposable and non-mirror images are simply called as an diastereomers. Their properties of diastereomers differs from enantiomers, and diastereomers may not be an optically active or optically inactive compound. So, the generally called diastereomers are stereoisomers, which is not a mirror images and which is non-superimposable on one another, and sometimes it is very difficult to determine whether the two molecules are diastereomer or not. And stereoisomers with two or more stereocenters can be diastereomers. This the example is given here. Similarly, diastereomers having various examples I have pointed out here in the case of alkene system, cis-trans isomers, and general trend about in a cyclic system about cis 1,4 dimethyl cyclohexane, trans 1,4 dimethyl cyclohexane system for knowing about the diastereomers. Some more examples about the diastereomers. See, these compound which is having a mirror image with each other are said to be a enantiomers, and this enantiomers, but these two compounds are diastereomers. Similarly, some more examples that with D-glucose and D-aldose and D-glucose, D-mannose are the some more examples about the diastereomers. And the compounds with the two stereocenters, here these two are diastereomers, these two are diastereomers, these two are diastereomers, these two are diastereomers. And this is a very important aspect about the comparison among enantiomers and diastereomers. Enantiomers are stereoisomers which is having a mirror image, but diastereomers or stereoisomers do not have a mirror images. Enantiomers having a physical properties and chemical properties are identical, like a melting point, boiling point, density are expected to have a same properties. Only when there is a change in the plane polarized light rotation, rotate the plane polarized light in a opposite direction, only a enantiomers differs. But in diastereomers, because these are different compounds, so they have a distinct physical and chemical properties. Enantiomers are present as pairs of isomers. Diastereomers can be several compounds. And due to the similar physical chemical properties, the enantiomers are very difficult to separate it, like our fractional distillation or crystallization. But diastereomers having a different physical properties and compounds are different, like cis and trans, so it is very easable for separating like fractional distillation or crystallization method. And enantiomers having a same molecular shape, but due to different compounds, the diastereomers having a different molecular shape. So enantiomers have one or more asymmetric centers, but diastereomers may or may not have a asymmetric center. For example, for enantiomers, lactic acid and tartaric acid example in the case of diastereomers. Thanks for watching this video. Like it, subscribe it and share it. Have a nice day.